Welcome to section 9.2, constructing intervals for a population mean. But this part of the video is going to go over how do we find a t-critical value using the TI84. That means there is a function in the TI84 that can also help us find the t-critical values. We already talked about using the function critical t from the Math 200B program, right? But this video will concentrate on using a function that already exists in our TI84s. Just a quick reminder that the notation T sub alpha means that the subscript right here, alpha, is the area to the right of the T. So we're looking at a distribution over here. This T curve is centered at 0. So we're finding this T of alpha because the values not here on the number line are T's. That means that the area on the right hand side is the alpha. That means is the subscript. So how do we use the TI84? The first thing is finding the degrees of freedom, which are n-1. So always keep it in mind what they are. And the function we're going to be using here is called inverse t, which is similar to that of an inverse norm. In an inverse norm, you need the area on the left. So with inverse t, you also need the area on the left. It's just with inverse t, the only other thing we need are the degrees of freedom. So depending on which area the problem gives you, you always need to make sure you have the area on the left, and that's the one we enter into the inverse t. Once you hit paste, click enter, we're going to round our final answer to 3 decimal places. So let's look at some examples. Find the t values given the area under the t distribution. In this case, the area is to the left of the t is 0.20 with 10 degrees of freedom. So let's go ahead and just draw real quick what's going on. So here's the t distribution, center at 0. So we're looking for a t so that the area on the left, as right here the problem's given, is 0.20. So that means the t is going to be on the left-hand side of 0. So this area on the left of t is 0.20 as the problem said so. Okay. Now, the function, the inverse t function needs area on the left, which we already have. So we can just jump into finding the value of t. Inv t, the area on the left, 0.20. And we're also going to need the degrees of freedom, which in this case is 10, because those are the ones we're already given. So df are 10 as the problem states. And so all we have to do is just go to our TI84 calculator. So let's go ahead and do that. Go ahead and turn this on first. All right, so we're going to go to second vars, and right there is where we found the inverse norm earlier to find z critical values, but now we're going to use inverse t to find t critical values. Click enter. So it's going to need the the left tail or area on the left. So we're going to type 0.2 or 0.20, same thing. And then we're going to type the degrees of freedom, which in this case are 10. And so the t is, and here makes sense, that is negative because the t is on the left hand side of 0. So it is negative 0.879, rounding to 3 decimal places, and that's our final answer, and we're done. Let's try one more problem. So now we have the middle area of the t values is 0.95 with n, which is the sample size of 15. So again, let's go ahead and see what's going on here with a picture, since now we're given the middle area. So the middle area, so here's 0, given to us is 0.95. So we're trying to find two t's, one here on the left hand side and one on the right hand side. The one on the left hand side, the one in blue, right? We know for either one we're going to use an InvT. But remembering that we need area on the left. Well, for this t, we don't have the area on the left, so let's go ahead and find it. We can find the area under both tails, actually. So if 95 is in the middle, think of it as 95%. That means there's 5% more that is needed to complete the whole graph. Now from those 5%, half of it is on the left tail and half of it is on the right tail. So half of 5% is 2.5%. In decimal form, that'll be 0.025. So that's on one side and on the other. So that way we complete 100%, or in this case, 1. So the area on the left of this T in blue is the 0.025, and so that's the area that we enter, right? The area on the left. So 0.025. Now degrees of freedom, here we have to be careful a little bit, because if the sample size is 15, then degrees of freedom is equal to n minus 1. That means 15 minus 1, and so this is going to be 14. So degrees of freedom are going to be 14. And so we can just go ahead and use our calculator to find this value. So again, we go to second vars, InvT, click enter. So now the area on the left is 0.025 with 14 degrees of freedom. And so our answer is negative 2.145, rounding to 3 decimal places. So the answer is negative 2.145, rounding to 3 decimal places. Now the T in green, right? We can also do an inverse T if you want, or you can just use symmetry. Here, using symmetry, you can see that the T is going to be positive 2.145, and then you're practically done. If you want to go ahead and do the inverse T, then you would do InvT. Now the area on the left of this one's a little, you have to take a little bit, sort of one step, because the area to the left of the green one is the 0.025 combined with the 0.95. So that means is 0.975. Degrees of freedom are still the same as 14. And so you can verify this with the calculator that you're going to get the positive 2.145. So let me go ahead and verify this. Inverse T now is 0.975 with 14 degrees of freedom. And there you have it. Is now the T on the other side is positive 2.145. So these are the two T's, so that 95% of the area is in the middle. So these two examples, they give us the area. Let's look at one where they give us the confidence level. If they give us the confidence level, and let's say we're trying to find the critical value of T, remember that the critical value is T of alpha over 2, then the confidence level here is 90%, and therefore that makes alpha to be 5% or 0.05. So alpha over 2 is 0.05 divided by 2, which is going to be, oops, sorry, I think I made a small mistake here. If the confidence level is 90%, then alpha is not 5%, alpha is 10%, so 0.1. And so half of, I think I was already thinking the 0.05 in my head, that's why I wrote it there. Alpha is 0.1 divided by 2, then we get the 0.05. Okay, so if we're trying to find the T sub alpha over 2, which is the critical value for a confidence level, when we construct a confidence interval, then this is, you're looking at T of 0.05. But keep in mind that the subscript is the area on the right, but the inv T needs the area on the left. So that means we have to do the 1 minus. So we have to do 1 minus alpha over 2, which is 1 minus 0.05, and so that's going to be 0.95, and that's what we're going to enter in the inverse T function. So 0.95. Degrees of freedom here, well, n is 35, So degrees of freedom are going to be 35 minus 1, or in this case, 34. And that's what we enter, 34 for degrees of freedom. So let's see what we get. So over here in our calculator, we go to second vars, inverse T, enter. Area on the left is 0.95 with 34 degrees of freedom. Click enter. And so here's our critical value, 1.691, rounding to 3 decimal places. And so we are done. There is one more example with 99% confidence level. I have the result here over here. So go ahead and give it a try on your own, and then check with this result and see if you get the same thing. And so I'm going to stop right here.